Okay, guys, so I'm actually going to go through 1.1. I'm going to do like core concepts, and I should probably try to write neater than this. Sorry. In core concepts, I'm just going to kind of give you the gist of what this section is about, and then I'm going to use the packet and make another notes video for that where you can kind of practice what you're seeing on here. So the core concept today is going to be linear equations. This is something you should already know how to do. It's going to be probably the most common that you would remember is y equals mx plus or minus b. Keep in mind that this is your start value. You guys would have thought of it as the y-intercept. And this is going to be your slope or your rate of change. Keep in mind that if it's going up from left to right, your slope is going to be positive. If it's falling, it's negative. If it is horizontal, and this is where people kind of keep forgetting what's what, so these two exceptions mess people up. Horizontal, you're going to have a slope of 0. Think of it like your roof. If it goes up, it can go down, and it can go flat, but your roof cannot do this. And so if you have vertical lines, then your slope is what we call undefined. So those are kind of things that you have seen in the past. If you have a line, for example, here, let's say I had y equals 50x plus 10. Well, then it would start here at 10, and it would be going up 50 for every 1 unit. So if I'm counting up here, it'd be going up 50 over 1, up 50 over 1. So I'd have a line that looks something like that. Okay, so that's kind of just the very, very basics of what we've done in the past. Also keep in mind that when you're trying to find the slope, if I have a point here and I know that it has some x value and a y value, which we creatively call x1, y1, then it might have another value over here, x2 and y2, so the second x and y value, and I'm looking for the line that goes through those. Alrighty, so your slope formula is to take that second y, subtract the first, because by subtracting the y's, you're finding out how much of a rise there is. So if you remember rise over run, then you're also going to figure out how far over does it go. And so that you're going to figure out by the change in x, so you would have to take x2 minus x1. So all of this we've done before, but these are just kind of some core concepts that we want to be able to use. So whether it's a graph or an equation or a word problem, this is going to be where we say, okay, they're talking about the starting amount. So that's going to be this value. When they start talking about the rate of change, or a lot of times they'll use the word per, per pound, per hour, then you're going to be using that as your slope value. Keeping in mind these kind of special situations, slope of 0 is horizontal, a slope that's undefined is from a vertical line. These are called obliques over here, or slanty lines, and that's where you're going to be utilizing this formula. And that's going to be when you do the majority of your work is with slanted sloped lines. It's not that, once you get to horizontal and vertical, there's not a ton of things you can do. This is going to be for oblique or kind of slanted lines. So that means that horizontal and vertical are going to be kind of exceptions to the rule. So let's take a look at that, because that is something that people commonly get wrong. A horizontal line, if you were drawing that on the x-axis, xy-axis, would only cross the x. So here, let's do it this way. Sorry. If this is x and this is y, and you decide that you're going to draw in a horizontal line, that is only crossing the y-axis at some value n. So the horizontal line equation is just going to be y equals a number. There's no x in it. I always think of it as the variable that you see tells you what axes it crosses. So this only crosses y, so there's just a y. Whereas up here, these oblique lines will cross both the x and the y axes. And so both of those appear in my equation. So then let's think about a vertical line. So if I had my X and Y axis again, think about what that's going to cross. Well, that's only, if I drew in a vertical line, that's only going to, this was horizontal, sorry, that's only going to cross over the X axis. And so my equation is only going to have an X in it and then indicate what number it's crossing at. So if this was like X equals 2, then my line would be at 2. If this was Y equals 1, then my line would be at Y, or across the Y at 1. So keep in mind those exceptions. Horizontal has has a 0 slope and a Y only equation, no X in it. Vertical has a slope that's undefined and it only has an X in the equation. Those two exceptions usually mess people up because they try to follow all these other Y equals MX plus B rules, and there's no such thing. So you have over the years done a few different formats of the linear equations. Linear equations are anything that makes a line. So we're going to talk about this one, which we all know pretty well. This one's our slope-intercept, because it shows us the slope and the y-intercept, so that makes sense. And when I do that, when I write that, I'll have this y and this x in the equation, and then I'll be replacing b with wherever it crosses the y-axis and m with the slope. So those will become actual numbers. So for example, you would have y equals 2x minus 5 maybe. So this x and y stay in the equation, the others become variables. Something that you will start to use in calculus, and since we are in pre-calculus, now is a great time to talk about that. If I knew the slope and I knew 1 point, then I could use, I'm going to actually get rid of all of that, this format that we call the point slope form. That's the more common name, so I want to make sure you hear it that way. Point slope, these are telling you exactly what's in it. So if you knew a point like an x1, y1, and you knew the slope, then you could easily use this formula. So the formula is that you take y minus y1, which is going to be from the point it goes through, equals m, and then times x minus x1, which is the x value that it went through. So again, if I think about what's going to stay variable and what's going to become a number, this is going to be an x in my equation, and this is going to stay y. Everything else is going to be a number that I either got here, comes out of the x coordinate of my point. This will be a number that came out of the y coordinate, and then the slope will be the slope. So if I knew, for example, that it's going to go through -2, 3 with a slope of 4, I would have y minus 3, because that's my y1 value, equals, and then my m value, so 4, and then x minus, but it's a -2, so minus -2 becomes a plus. So that would be the equation in point slope form. If I'm supposed to write it in slope intercept form, all I have to do is simplify. So I distribute my 4, and then I add my 3. So this is going to be the same exact line. If I drew this one or I drew this one, I'd end up with the same exact line. They're just in different forms. And because in pre-calc, we're kind of looking back at algebra, that's what we would have used in algebra. But as we go into calculus, you're going to find that they use this one more often, and so we'll start using that a little bit more. Just a couple more real quickly. If you have a general form or standard, then that's going to be like something x plus or minus something y equals something. So for example, and again, this would stay y and this would stay x. So for example, I might have 2x minus 3y equals 8. That would be like an example of a general or standard form equation. Okay, so in the notes there's a 2-point formula. I'm not even going to go over that because you just never use it, so it doesn't make any sense. So all of these, that I just talked about down here, all these different equation formats, that's what we're going to use to write equations. So they're going to give us information, and we're going to write the equation that's easiest based on what information we have. Do we know the slope and the intercept? Then we'll just use that formula. Do we know a point and the slope? Then we'll start with this formula. You almost never start with general because it's hard to find information. So the notes packet has a lot of examples, and I'm just going to make a different video that you can then use to see how these look in action, because the notes will be a lot like your homework packet. And so that way you can see the practice packet in the notes and then be able to hopefully do your homework in class really successfully. Thanks, guys. See you, well, I guess I'll see you on whatever day you're in class next. Bye, guys.